What if the tiny particles that will shape our future technology can be both on and off at the same time? Or maybe neither. And get this, the simple act of looking, of just measuring them, forces an instant decision in a way that still puzzles the smartest folks out there. Ready to see things a little differently? Today, we're exploring the very strange and wonderful heart of quantum mechanics, specifically the world of qubits. These are not your typical bits of information. Nope. They exist in a sort of haze of probabilities, a world of maybes and what-ifs, right up until we try to get a look. And when we do, something called wave function collapse happens. It's a super fast, pretty dramatic jump from all those possibilities to one single solid answer. Sounds a bit like magic, doesn't it? It's definitely mind-bending. But we're going to pull back the curtain on some of that mystery. Our main tool for this? A surprisingly neat visual called the Bloch sphere. This isn't just some abstract diagram. It's a map that lets us see what's happening with a qubit. We'll get to visualize a qubit state, watch that dramatic collapse, and hopefully make one of quantum's most famous tricks a lot less confusing. So, let's get started and break down how qubit measurement really works. What is a qubit? The quantum building block. Before we can really get a handle on the Bloch sphere, we need to meet its star tenant, the qubit. You're probably familiar with classical bits, the basic units of info in our everyday computers. A classical bit is straightforward, like a reliable old light switch. It's either a 0, think off, or a 1, think on. That's all. Two states, nice and clear. Qubits, however, are playing a whole different ballgame. They're the quantum version. A qubit can also be a 0, and it can also be a 1. But here's the quantum twist. It can be a 0 and a 1 at the very same time. This wonderfully weird feature is called superposition. Picture spinning a coin. While it's up in the air, spinning like crazy, is it heads or tails? You could say it's kind of both, right? A blur of possibilities. It's only when the coin lands, when it stops moving, that it picks a side, either heads or tails. A qubit in superposition is a lot like that spinning coin. It holds the potential to be a 0 and the potential to be a 1 all at once. Mathematically, we write this state as a mix of ket 0 and ket 1. Think of these as the basic quantum states, like our classical 0 and 1. A qubit state, often written as the Greek letter psi, can look like this: alpha 0 plus beta 1. Now, alpha and beta aren't just random numbers.